Road to Olympiad.
Welcome to RTO. Consider the following problem. Let a and b be positive integers such that greatest common divisor of a and b plus the lowest common multiple of a and b is a multiple of a plus 1. If b is less than or equal to a, show that b is a perfect square. Perfect square have a lot of synergies with greatest common divisor and lowest common multiple. Here today we are going to play around with Euclidean algorithms to show that b must be a perfect square. Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by letting the greatest common divisor of a and b be d. Then we have a is equal to dx and b is equal to dy for some integer x and y such that x is greater than or equal to y, as well as the greatest common divisor of x and y is equal to 1. Here we can further calculate that the lowest common multiple of a and b must be dxy. Now it's given that the greatest common divisor plus the lowest common multiple, as in dxy plus d, must be a multiple of a plus 1 or dx plus 1. Some simple calculation can show that dxy plus d minus y times dx plus 1 must be a multiple of dx plus 1 as well. Simplifying the expressions, we have d minus y is a multiple of dx plus 1. However, notice that dx plus 1 itself is definitely greater than dx. And this is greater than or equal to the maximum of d and x. Equality achieved if one of them is equal to 1. And from the fact that x is greater than or equal to y, we must have this is greater than or equal to the maximum of d and y as well. And for sure, this is greater than the absolute value of d minus y. As d and y are both positive, their difference must be smaller than the greater number. And thus dx plus 1 is greater than d minus y. This is impossible as d minus y is a multiple of dx plus 1. Not to mention that dx plus 1 is a positive number. So this is possible only when d minus y itself is 0. And this gives us d is equal to y, or b is equal to d times d, which is d squared, which is a perfect square. And this marks the end of our solutions. Post in the comment below if you have any thoughts on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.